Question 6, part D, asks to show that the area, so this area of the inner surface of the container that we're calling A, is equal to pi r squared plus 1 million on r. And you may be thinking, well, what's the point of that? What are we just rearranging equations for? Well, we have previously found out an expression for this area in part A. I'm just going to recap that from A. This is part A, capital letter A, so the area of the inner surface of the container is pi r squared plus 2 pi r h. So just to go back what I was saying, you may be wondering, well, what are we doing here? Just proving our algebra skills by rearranging equations. But the key difference between this formula and this formula is this top formula doesn't include h. So we actually don't need to know the value of h to find the inner surface of the cylinder. It's quite neat. We're actually backing out one of the variables and then left with just the radius. So we need to show that the area can be equal to this formula. I'm going to build off from this area formula here that we found in part A. So area is equal to pi r squared plus 2 pi r h. Now, 2 pi r h is looking very close to the right hand side of our volume of a cylinder. So I'm just going to write out that again. Actually, I'll say from C, 500,000 equals pi r squared h. Now, I know I want to get it in terms of a number of million, and I currently have 500,000. So what if I was just to multiply this equation by 2? And if I multiply an equation by 2, I need to multiply both sides by 2. So this becomes 1 million, because 500,000 times 2 is a million, is equal to, now also multiply the right hand side by 2 as well, it becomes 2 pi r squared h. Now, what if I was to divide both sides by r? And you may be wondering, what's the point of that? But it'll be clear in a second. So, sorry, I've missed a 0 out of this number. That should be 1 million. I'm now going to divide both sides by r, and that becomes 1 million divided by r, because I need to divide both sides by r, will equal 2 pi RH. Now I don't need to do a division of r here, because when I divided the right hand side by r, this r squared just becomes r to the power of 1, because r squared on r just becomes r. Okay, so just to pause now, we have this expression here that 1 million over r is equal to 2 pi RH. And if I was to now bring this equation down, area equals pi r squared plus 2 pi RH. Let's have a look at the right hand term, 2 pi RH. Well, I know that 2 pi RH is equal to 1 million on r. So therefore, instead of writing 2 pi RH, I could sub in what it is equal to, which is 1 million on r. And we have now got to the equation that we were meaning to initially show. Area equals pi r squared plus 1 million on r. We have now shown that using this expression for A, the very initial one, and also this expression for the volume. We've kind of combined them together. We've done a bit of rearranging, combined it. We made use of the fact that we knew that the volume had a number in it of 500,000, and then we sort of did some algebra magic and got down to an expression for A that doesn't include the height, which is quite neat because it only has one variable now, the radius. So there we go, there's the answer to part D, question 6.